Welcome to Lesson 114, Systems of Linear Inequalities. Here's our objective, our vocabulary, our rules and notes. Please read through these things to get an idea of where the lesson is going. Pause the video and read them. Okay, so basically when we're talking about systems of inequalities, it's just like systems of equations. But instead of looking for the point of intersection, we are looking for the solution, which is all points in the region. So there comes a point in that time, let's look at the red line, where the red line is doing something and everything below would be a solution set. And then the blue line is doing something. And then where those two lines cross, all of these points in between both solution sets would be is the solution. So all of these points would satisfy both equations. And that's what we're talking about. So we're talking about points that satisfy both equations. Okay, find a solution set to y is less than x minus 1, y is greater than 2x minus 1. So the first thing we're going to do is graph it. Since we have x minus 1, x minus 1 is here. I'll do it in black. The slope is 1. So we go through every corner of the box. And because it is less than or equal to, it is a solid line. And so we know that it's going to be everything below. And I'm just doing little lines right now. So let's do this one in red. Negative 2x minus 1. When x is 0, y is negative 1. Our slope is negative 2 over 1. So that means we go down 2 and over 1, down 2 and over 1. To the left, we go up 2 and over 1, up 2 and over 1. We have a dotted line. And we're going up. So because we're going up and the black one was going down, this is our solution set. All points in this shaded in area, let me shade the area in a different color so it makes sense. Because I'll do the algebra only on the first one so it'll make sense to you. So let's shade the area in blue. So this is our solution set. Everything in here is below the black line and above the red line. So let's pick a point, 2, 0. 2 zeros in the solution set. I should probably put that in a different color so you can see our point. 2 zeros in the solution set. So on this one, 0 is less than or equal to 2 minus 1. 0 is less than or equal to 1. That works. 0 is greater than negative 2 times 2 minus 1. 0 is greater than negative 4 minus 1. 0 is bigger than negative 5. So our solution set, any point in the solution set has to satisfy both inequalities. And that's what we mean. So I will not do the algebra on the other one unless it specifically asks. So keep that in mind. Okay. All right. The RVM company, let's look at a real world examples. Make sleds and wagons for toddlers, 10 red sleds and 15 brown wagons. The number of red and brown sleds can be produced cannot be more than 20. So here we go. So we got 10 red and 15 brown. And then red plus brown cannot be more than 20. So less than or equal to 20. They cannot manufacture in excess of 10 red sleds and 15 brown wagons. Okay. So we don't have 10 red sleds. They can't manufacture in excess. So we have red is less than or equal to 10. Brown is less than or equal to 15. And then red plus brown is less than or equal to 20. So you can see how in a real world situation we have a range of numbers or situations that we're dealing with. So let's try to graph it on the next slide. Okay, so let's look at our situations. We had our red sleds was less than or equal to 10. Our red sleds, yeah. Our brown wagons was less than or equal to 15. Our red plus brown is less than or equal to 20. So we're going to say X is R and B is Y. And so when we go to graph this thing, B is less than or equal to negative R plus 20. And so when R is 0, B is 20. And so let's graph it. All right, so I'm going to use red sleds as red, obviously. And if R is X, so we're looking at 10. 10 is for the red sleds, which is red. The brown, I'll use blue. So our line is 15. So these represent brown sleds because brown is Y, brown is close to blue, so I use blue. And then we need our red plus blue, so we need to graph this line. So we graph this line in red, we graph this line in blue, we're going to graph this line in black. And so it's dropping down, as you can see. At 1, B is 19, 2 is 18, 3 is 17, 4 is 16, 5 is 15. So 5, 15 for the black line. And then our slope is 1. And it's a solid line. So basically all of these work. So let's show you how to use your X's and your Y's. Now, if you make one red sled, you can make 15 brown wagons. So your wagons are here. And your red sleds are here. For 2, you can make 15 and still be under 20. For 3 red sleds, you can make 15 and still be under 20. For 4 red sleds, you can make 15 brown wagons and still be under 20. For 5 red sleds, you can make 15 wagons and be equal to 20. So now watch what happens when we get to 6. When we get to 6, you can only make 14 wagons at the most to be at 20 or under, at the most 20. And you can see now how this line affects everything and what we're producing. So that is how you solve a real world problem with systems of linear inequalities. So those were our 2 examples. Please try to practice problems, and I will see you at the end of the video for a recap. Okay, so let's solve the system. We're going to graph these lines. X minus 4. Y is negative 4. So this line is going to be black. This line is going to be red. And the solution set will be in green. And I'm graphing these, just using graphing negative 4. The slope is 1. So it's going up on each corner of the box. And it is a solid line. And up. So that means it's going up. And I'm going to just do short lines now. So y is 3 minus x, or y is less than negative x plus 3. You can always switch things around. So when x is 0, y is 3. We're going down by 1. And we have, it's not underlined, so it's a dotted line, which means no solution lies on the line, and we're below. Yes, we are. We're below. Less than is below. So everything, every point in this region will work. And what I suggest you do is you take 0, 0, and put them into both equations and see what works. Okay, again, we'll do this line in blue, this line in green, and the solution set in black. So you got to move your x over here. So y is less than negative x plus 3. I felt like I just graphed that line. It's not underlined, so it's a dotted line, which means no solution lies on the line. And then, okay, I was supposed to graph that in blue, I'm sorry. Let me change both of these. I'll make this one green and then this one blue. So now we're all good. Y is greater than or equal to x minus 1. So that means when x is 0, y is 1 minus 1. And slope is 1, so it's going up. And every point on the line works for both equations. And so if we're above this one and below this one, so our solution set is every point in here. And finally, 3x. We're going to graph this one in yellow, this one in red, just to give you different colors. 3x. 0, go over 1, go up 3, go over 1, go up 3, over 1, down 3, going left, over 1, down 3, going left. And connect the dots, greater than, so that means everything above the line. All right, now let's graph the red one. Move the x over. Y is less than or equal to negative x minus 2. When x is 0, y is negative 2. Down. Solid line. Because it's underlined, the inequality is underlined. And less than means going down. So above the yellow line, below the red line is all of this in here, is this whole section in here. So every point in that section works, and that is how you solve linear inequalities.